Okay, so this is the first video of the P1 section of these revision videos. Now P1 is about the Earth in the universe, and it's really important to remember that it's not just about space, okay? Half of the module, the latter half, is actually about the interior structure of the Earth and what it's made of and tectonic plate theory and that kind of thing. But today we're going to kind of review, to start with, the basics about space that you probably already know or might have just about forgotten. The first thing we're going to look at is the solar system, and the solar system is what you probably know most about because it's where we are. Now, the solar system is a type of planetary system, and a planetary system, as it says there, a star and the planets and other objects that orbit around it. Now, the solar system is just an example of this, and it's got a special name because it's about us, and we like to give things that we're in their own names. Now, it's called solar because our sun is our star that it's talking about, and anything to do with the sun, we say solar. So a planetary system, like e.g. the solar system, here we go, is just a star, or our sun in this case, with the planets that's going around it. And the planets we know from down here are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, and I'll come on to those in a minute. Now when it says other objects, like here, this mainly means comets and asteroids. Now comets are icy balls that shoot around the sun in elliptical orbits, okay? They're made of frozen gases and dust. They're often known as dirty snowballs, and they have highly elliptical orbits, and we'll go back to what that means in a second. Asteroids are quite different. They're big rocky chunks that aren't usually spherical. They're irregular in shape, and they orbit the sun as well. They're kind of the leftovers from the formation of the solar system that didn't make it into planets, and we're going to talk about that in a few minutes' time. So the planetary system, or the solar system here, we have the sun in the centre, nice yellow blob, and then around it we'll be orbiting lots of planets, and we're just going to draw one orbit. Now planets orbit in a kind of elliptical fashion as well, and elliptical just means oblong, okay? It's not usually a perfect circle. So they orbit around the sun, they travel like this, and a year is just how long it takes the Earth, or any other planet for that matter of time, for that matter of fact even, to get around the sun a complete cycle, okay? Now there are 8 planets in our solar system nowadays because we've decided that Pluto is no longer classed as a planet. We'll talk about that, why that is in a second. If I draw this here, if we have the sun at one side, so my nice big yellow sun, then the first 4 planets that come along are Mercury, Venus, Earth and Mars. Now you'll see that I've drawn them absolutely little tiny dots, and even though I've done this, it's still not to scale. We're going to come onto these as a group in a minute, but I'm going to carry on for a second. The next planet we get to then is much, much bigger. We get Jupiter, which is about maybe this size, okay? Jupiter's the biggest planet in the solar system. We then go on to Saturn, which is a little bit smaller, and Saturn is obviously really famous because it's got some nice rings around it that are visible with a telescope quite easily. We then go on to 2 more gas giants called Uranus and Neptune, and they're both bluish, so I'm going to draw them both in the same kind of colour. And they're about the same size. Now Uranus has got an upside down ring, not upside down, a vertical ring, and Neptune also has a really thin ring, but we don't often talk about it. As a matter of fact, Jupiter has some really thin rings as well, but they're so thin that it's not worth drawing on there. Now, obviously at the end there, what we're missing, or what people used to think there was a planet, we have Pluto. Now Pluto is even smaller than Mercury, so it should be a smaller dot than that. But Pluto is now a dwarf planet, and that's because its orbit is not particularly, it's really, really elliptical, which they don't like. They think that's more like a comet-esque thing. It's tiny and doesn't really follow the pattern of planets, and the main reason that it's not a planet is because it hasn't cleared its orbit, which is a really technical thing to say, but the Space Agency, the International Astronomical Union, IAU, decided that a planet has to clear its own orbit, and the Pluto just haven't done that. And there's other asteroids which are about the same size as Pluto that aren't counted as planets, so they thought, let's just put that down as a dwarf planet, and it's nice and clear. Now, there's one thing kind of missing on here that you might have known about, and that's something called the asteroid belt. Now, the asteroid belt goes between Mars and Jupiter, and it's a big rocky belt of lots and lots of asteroids, and I'm going to just draw those in here. Okay? Asteroid belt. And that's where the majority of the asteroids in the solar system are. The final thing we're missing are comets, which are just written up there. Now a comet, as I said, has a highly elliptical orbit, which means instead of going around the sun like this, it might go around the sun, you won't be able to see the end of it, in this kind of fashion. So it's even more of an ellipse, or even more of an oval than normal. So this might be a comet. Now they can be anywhere in this line up because it depends whereabouts in their orbit they are. So comets are also shooting around. I'm just going to draw them in here. And they've usually got a tail, like that. So there's two types of planets here. We can see at the start there's these really small ones. Now the thing about this diagram is even though I've drawn them kind of to scale in terms of sizes, the diagram is no way to scale because I can't fit it on the piece of paper. If the Sun was this size, then Mercury would be a much smaller dot than this, and it would be about 3 meters away. Saturn would be about 500 meters away. So I can't actually, that's a bit of a lie actually, it would be about 80 meters away. When we get to Pluto, that would be about 500 meters. So we can't fit it onto a piece of paper, but we can use our imagination and think. Now these first 4 planets here, they're all very similar because they're all small, although you think the Earth's quite big. Actually, in the grand scheme of planets, it's quite small, and they're all rocky. Okay, they're made of rock, and they're called terrestrial planets because of that. Now, conveniently splitting up our terrestrial planets in the next lot is the asteroid belt, which is a nice big belt of rock. Now, after that, we don't really have terrestrial planets anymore, apart from Pluto, which isn't our planet, so we can ignore that. We have here instead our gas giants, and they are, as the name suggests, made of gas and really, really big. Now, if you tried to land on a gas giant, you wouldn't, you'd go straight through it. So they haven't got a solid surface, okay? They are made completely, apart from maybe the very centre, but we're not completely sure, of gas. Now there's one more thing to think about. A lot of these planets, at least 6 of them, have got moons. So we've got one, I think Mars has 2, Jupiter's got 4 big ones and then lots of others, Saturn's got about 60, and Uranus and Neptune have got a couple as well. Now a moon is just an object that orbits a planet. So it's called a natural satellite, okay? So if I've got my planet here, the planet orbits the Sun, then a moon orbits a planet, and that's how you define a moon. Now we call our moon, moon with a capital M, so this is Earth here, isn't it? And we have our moon with a capital M. But other moons are just called moon with a little m, so that distinguishes between the two. Okay, so that's the thing to know about the solar system. It's important to know the size of these objects, not in actual kilometres and that kind of thing, but to know the scale. So it's important to know that the Sun is much, much bigger than the next biggest thing, which is Jupiter. It then goes Saturn, Uranus, Neptune, then Earth, Venus, Mars, Mercury, asteroids, comets, and Pluto is around about the Mercury asteroid boundary. So it's important to know that order as well. Okay, so moving on to the formation of the solar system. So, the solar system was formed about 5,000 million years ago. Okay, 5,000 million years ago. Now, in a lot of places around the world that isn't England or Britain, we would say 5 billion, and that is much, much easier. But the British say that 5 million is a billion, not 5,000 million. So we need to use that, the proper nomenclature for when we're talking about our exams, and that is 5,000 million years. So this formed about 5,000 million years ago. Now this here is just a giant cloud of gas and dust. Now it probably came from a supernova. Okay, it's a giant cloud of gas and dust, and we'll talk about supernovas in the next video. Now this big cloud, there's some parts in the centre of this cloud that are a bit more dense than others. There's more gas and dust collected together, and those parts have got more gravity, because gravity, for reasons you don't need to know, is all to do with about how much mass that you have. So somewhere that's got a lot more mass is going to have a lot more gravity. Now this gravity causes the cloud of gas and dust to start to collapse in on itself, to kind of start to clump together, and we come to this stage here, which is where the centre has started to really get quite dense, and then the outside are a bit flatter. Now, gravity's caused this to clump together, and it's also caused the solar system, or the cloud of gas and dust that will become the solar system, to start to spin really quickly. And this spinning makes it into a nice flat plane. So these spirals you can see here are really thin, and we've got a really central kind of big spherical bulge in the centre. Now this is going to become the Sun, and these will become the planets. So it becomes the Sun, and these will become the planets, becomes planets. And this is all due to gravity, okay? So we've got a nice flat disk, and it's starting to spin around really quickly, and this carries on to here. And as it carries on, the central bulge gets denser and denser, and finally becomes so dense that fusion can begin, and we'll talk about that in the next thing. So it's become the Sun by now. And then around these edges, we start to get the planets forming. So the places where there are lots of gas and dust in these little edge bits, more gravity clumps these together, and we start to make planets. So the planets form around in these spirals. Now, these spirals contain lots and lots of debris, so we have got these as planets now. And they begin to sweep up. The debris that's left around is swept up by these planets. And eventually, we get the solar system we have today. Okay? With the sun in the centre, the planets orbiting all in about the same plane, which means it's quite a flat orbit. And then the debris is mainly constrained to the asteroids here. So this is mainly the debris from the leftovers of the formation of the solar system. So you don't really need to know that in that much detail, but you do need to know that from 5,000 million years ago, the solar system was formed from a cloud of gas and dust. And it's useful to know that that happened due to gravity, and that the gravity caused the gas and dust to spin and compact into the sun, and then it flattened into a disk, and those disk parts, the debris, collected together and became planets. So now we know what a solar system is and how the solar system was formed. We can look at the actual structure of the universe. Now we can see here, this is the sun, and this here is Earth. Okay, so the Earth, we know, orbits around the sun. The sun is a giant ball of gas, and it's not very special. There are thousands of millions of suns, or stars, because the sun is a star. There are thousands of millions of stars in every galaxy. Now this we know is called the solar system, so I'm going to just label that there, solar system. Now each galaxy has got thousands of millions of solar systems in it. So galaxy, it's just a collection of thousands of millions of stars, which may or may not have planets orbiting around it. We're not sure. That's one thing that people are really looking into right now in the search for extraterrestrial life. So a collection of thousands of millions of stars. Now these stars, the vast majority are very similar to our sun, which we call the main sequence star, but we'll talk about that later as well. But some of them might be quite different. Some of them might be black holes, some might be neutron stars, some might be red giants, things like that. But the vast majority are just like our sun. Now our galaxy, as you probably know, is called the Milky Way. So just like we call our planetary system the solar system, we call our galaxy the Milky Way. And it's a spiral galaxy, which means it's got a bulge in the centre and then these arms coming off. And the sun is actually situated about here, in one of the outer spiral arms, about 2/3 of the way out. So actually, we're not in the centre of things, we're quite on the outskirts. If you had a telescopic lens and you then zoomed out again, so looking at the Earth where it is, zoom out, looking at the galaxy, zoom out again, you'd see that galaxies actually all come together and they cluster together in something called a galaxy cluster. Okay, so you usually find lots of galaxies close together. Now, when we say close together, they're really not that close, because our closest one is 2.5 million light years away, and we'll talk about that in the next video as well. But on the grand scale of the universe, it's actually pretty close to us. So a galaxy cluster is a collection of galaxies, which makes sense really, because it sounds like the word. Ours is actually called the local group, but that's not too important. If we then zoomed out one more time, we'd get to the kind of the larger scale structures in the universe, and that would just be the universe in general. So you'd then get the universe itself, and the universe just means everything that exists. Okay, the universe is everything. So when people say, can there be more than one universe? No, because then it wouldn't be a universe, because that's everything that exists. There might be multiverses, but that's definitely a question that you don't need to be answering in your GCSE. So the universe is everything that exists. So it's really important to know the structure of the universe and where you are abouts in it. On the bigger scales, you have a universe. You then zoom in, you see lots of galaxies clustered together. You zoom in again, you get to an individual galaxy. If you're looking at ours, it's called the Milky Way. You zoom in again, you get to an individual star with planets orbiting around it. And if you're lucky, you might have zoomed in on the sun, which has 8 planets. We're not particularly special, so there are probably plenty of other solar systems or planetary systems just like ours around the universe. Whether there's life on that is a different question and not something that we need to think about right now. But the important thing to know is that we are not in a special place in the universe. We are just part of a galaxy, which is then part of a galaxy cluster, just like any other.